A video claiming to reveal the Interstellar Comet, three-eye atlas races across social feeds, hailed as a triumph of skywatching. But experts spot immediate red flags: missing starlight, suspiciously smooth motion, and not a hint of a cosmic tail. The truth: this viral comet was born in a drop of water, not deep space. So why did so many believe? And what does the real three-eye atlas actually show us about worlds beyond our own? Every astronomer who glanced at the viral comet video knew something was off. In real deep sky images, stars are everywhere, tiny pinpoints, sometimes streaked by the tracking motion of a telescope. But here, the background was a blank void. No constellations, no faint glimmers, not even the digital noise that usually creeps in when a camera stares into darkness for minutes at a time. Lighting in the clip broke the rules of space photography. Instead of the steady directional glow cast by a distant sun, the object's brightness pulsed and shifted, more like a lamp under a microscope than any cosmic source. Shadows flicked across its body, but never in the way sunlight would sculpt a three-dimensional surface millions of kilometers away. Real comet footage always has a signature: the fuzzy halo of a coma, sometimes trailing a faint tail as dust and gas blow outward. Even the faintest interstellar visitor, like three-eye atlas, reveals a ghostly envelope under long exposure. The viral video had none of that, just a sharp-edged form gliding smoothly, untouched by the chaos of space. Sensor noise, too, tells its own story. Authentic astronomical images are full of quirks: hot pixels, random static, faint streaks from cosmic rays. These flaws are a byproduct of pushing digital sensors to their limit, gathering enough light from distant objects to make them visible at all. The viral clip was spotless, its motion glassy and uninterrupted, as if it had never passed through a real camera sensor at all. For professional skywatchers, these clues added up fast. If there are no field stars, no evidence of cosmic dust, no telltale camera artifacts, and no sign of a real comet structure, the odds of a genuine discovery drop to zero. The only thing left to examine is the digital trail: where the file came from, how it was edited, and what secrets its pixels might reveal. The visual evidence alone had already told the story. This was not astronomy. It was something else entirely, masquerading as a message from the stars. A digital forensics analyst stepped through the process, starting with a reverse image search of the viral clip. The search returned no matches in any major astronomical database, no NASA press release, no European Southern Observatory page, nothing in the minor planet centers logs. The file wasn't archived in any official comet survey, and the supposed three-eye atlas footage didn't appear in any legitimate sky survey results. Instead, every result traced back to social media reposts, each with a slightly different caption and none with a credible source. Examining the file's metadata revealed more gaps. The original upload, time-stamped October 26, 2025, lacked all standard camera information: no make or model, no exposure settings, no GPS coordinates. The EXIF data was stripped, a common sign of repeated downloads, re-uploads, and edits. Each time the video passed through another platform, more identifying details vanished. By the time it went viral, the only metadata left was a generic upload date disconnected from any scientific context. The analyst demonstrated a simple hash check. Every unique digital file has a fingerprint, a hash value, but the viral video's hash didn't match any known observatory archives or amateur astronomy logs. Instead, a ladder of reposts emerged. The earliest public version appeared on a social platform, posted by an account with a history of sharing AI-generated astronomy scenes. Within hours, the clip was recaptioned and spread across multiple platforms, each iteration further removed from any original context. Attempts to plate solve the video, a standard method for verifying astronomical images by matching star fields to catalogs, failed immediately. No background stars, no coordinates, nothing to anchor the scene in real space. The analyst checked for raw data such as FITS files or telescope logs. None existed. No amateur or professional astronomer could provide a matching observation despite the supposed magnitude and uniqueness of the event. A final check compared the viral file structure to authentic comet footage. Real telescope captures include irregularities, sensor noise, cosmic ray hits, or header data from the imaging device. The viral clip was uniform, clean, and generic, with no trace of the quirks that mark genuine astronomical work. The analyst concluded there was no chain of custody, no institutional provenance, and no reproducible evidence tying the video to any real observatory or mission. The digital trail pointed not to the stars, but to a string of anonymous uploads and missing context, a mystery that now called for a different kind of expert. A microbiologist reviewing the viral footage recognized the shape and movement instantly. The so-called comet was in fact a single-celled organism, most likely Paramecium caudatum, a common freshwater ciliate. Its body, oblong and slightly tapered, measured less than 1/3 of a millimeter long. What looked like a cosmic traveler gliding through emptiness was actually a living cell, covered in thousands of tiny cilia. These hair-like structures beat in perfect synchrony, pushing the organism forward with a rippling, wave-like motion. Under the microscope, this creates the illusion of a smooth, unbroken glide, eerily similar to the way a comet might appear to drift through space. The glow around the organism wasn't starlight or interstellar gas. It was the result of phase contrast, microscopy, a technique that amplifies subtle differences in how light passes through the cell's structures. This method highlights the edges of the paramecium, producing a luminous outline and a pronounced halo effect. In dark field or phase contrast mode, the cell's boundaries shine against a black background, making it appear as if it's surrounded by its own miniature coma. Cropping the field of view and boosting the contrast exaggerated this effect, stripping away any hint of scale or context. A quote from the microbiologist posted online the day after the clip went viral summed up the expert consensus. Those synchronized hair-like waves are textbook ciliary motion. Astronomers call it cosmic, but that's pure pond water. The cell's internal details, its nucleus, contractile vacuoles, and oral groove, are visible only to trained eyes. To most viewers, the shimmering outline and gliding movement evoked something much larger and more mysterious. But every feature matched the known biology of paramecium: the spiral swimming, the bright boundary, the absence of any tail or jet of gas. Even the flickering illumination, which some mistook for the play of sunlight on ice, was simply the product of microscopic lighting and the cell's slow rotation. The illusion held up only because the original context was missing. Once the organism's identity was confirmed, the mystery dissolved. What millions believed to be a message from deep space was, in reality, a drop of water magnified and transformed by optics. The next question: how did a biology demonstration become a viral astronomy sensation? A single drop of water magnified on a glass slide began its journey as a classroom demonstration. Somewhere along the way, its identity slipped away. The original video, likely recorded in a teaching lab with a basic phase contrast microscope, was uploaded to an open-access platform, unremarkable and clearly labeled as a biology resource. But as the clip moved through the digital world, credits faded. Each repost chipped away at the context, first the author's name, then the educational caption, until only the glowing, gliding form remained. When the clip reached a major aggregator, a new caption appeared: "Real 3i Atlas footage, closest ever," and the transformation was complete. Automated content tools picked up the trend. AI-driven news bots scraped the viral post, rewrote headlines, and generated short videos, all echoing the same astronomical claim. Within hours, the original lab setting was erased by a cascade of cosmic keywords and algorithm-friendly hashtags. The visual rhetoric did the rest. Cropping removed any hint of the microscope's edge, while contrast adjustments deepened the black background and exaggerated the bright outline. What started as a shimmering cell now mimicked the classic look of a comet, a luminous core, a faint envelope drifting through darkness. In this new frame, the scale was lost. A creature smaller than a grain of sand became, in the viewer's mind, an object crossing interstellar space. Pattern recognition is a double-edged sword. The human brain is wired to spot familiar shapes, especially when lighting and motion rhyme across different scales. The paramecium's cilia-driven glide, when seen in isolation, echoes the path of a comet caught in a telescope's gaze, Phase contrast halos mimic the glow of a real coma, but the resemblance is only skin deep. Physics, not appearance, defines what's cosmic and what's microscopic. As the video's reach expanded, so did the risk of confusion. AI-generated captions and automated reposts repeated the comet claim with growing confidence, burying the biological truth beneath layers of digital noise. The lesson is clear. In AI, a world of automated pipelines and viral visuals, what something looks like is never enough. Evidence comes from context, provenance, and the invisible details that don't survive 1,000 shares.